Human eye, as we know that eye is one of the most important part of our body. Because of eye, we are able to see this beautiful art. Because of eye, we are able to figure out different color present in this universe. So eye is very important, but eye has limitation when it suffers from defect of vision. So today we are going to discuss defect of vision in detail. So the first defect of vision is myopia. It is also known as nearsightedness. In this type of defect of vision, a person can see the nearby object clearly, but he cannot see the faraway object distinctly. This happens because image doesn't form at retina, but it forms before retina. The far point is much nearer than infinity. So the cause of myopia is the lens thickness becomes too large or the focal length becomes too small. For example, if the person is not suffering from myopia, his lens appears like this. But if he or she is suffering from myopia, his lens appears like this. We can see clearly the thickness of non-myopic person is this and thickness of myopic person is very large, due to which focal length decreases, and because of that image starts forming before retina. Now we will discuss this by using ray diagram. So as we can see, there is some parallel ray of light and they are coming from infinity. So because they are coming from infinity, they starts converging before retina. While in the second diagram, when ray of light is coming from far point, they converge at retina. Now far point is the maximum distance at which a person can see the object clearly. Beyond far point, which is this region, to infinity, a person cannot see the object clearly. So far point is the maximum distance at which a person can see the object clearly. Now we can correct this defect of vision by using concave lens. What concave lens do, it diverges the ray of light a little bit, due to which image shifted from the point before retina to the point at retina, and due to which we are able to see the object clearly. So this is about myopia. Now we will discuss hypermetropia. Hypermetropia is also known as farsightedness. In this defect of vision, we are able to see the distant object distinctly, but we cannot see the nearby object clearly. It happens because image form in this case beyond retina. The reason for this, because there is a decrease in the thickness of the lens, and due to which the focal length of the lens increases. For example, if a lens is like this in the case without hypermetropia, then the lens will appear like this in the case with hypermetropia. You can clearly see that the thickness has decreased. Because of thickness has decreased, the focal length will increase, and due to which image starts forming beyond retina. It can be corrected by using convex lens. Now we will discuss this by using ray diagram. So in the first, we have a near point from which ray of light is coming and it is converging at retina. Now in the hypermetropia, a person can see the far away object. That means from infinity to near point, a person can see the object. But if you place the object below the distance of near point, the image starts forming beyond retina, and here the person cannot see. So what we do here, we use a convex lens. Convex lens starts converging the ray of light from the point beyond retina to retina, and this time person starts seeing the object. So in this way we can correct this defect of vision, and in this way hypermetropia has been discussed. Now we will move towards presbyopia. So the power of accommodation of the eye decreases with aging. For most people, near point gradually recedes and the far point comes closer. And this defect of vision is called presbyopia. It happens because the ciliary muscles gets weakened and it diminishes the flexibility of eye lens. Such a person may suffer from both hypermetropia and myopia. To To correct this defect of vision, we use bifocal length of suitable power, in which upper part of the lens contains concave lens, which corrects myopia to see the distant object clearly, while the lower part contains convex lens, which correct hypermetropia to see the nearby object clearly. So in this way, we can correct presbyopia. Now we will discuss another problem in which a 14-year-old student is not able to see clearly the question written on the blackboard placed at a distance of 5 meters from him. Okay, so the first part of the question is asking, name the defect of vision he is suffering. So if I draw the ray diagram for human eye, it will appear like this. Now he was not able to see the object beyond 5 meter, right? Sorry, below 5 meter. Okay, so beyond 5 meter he cannot see. Below 5 meter he was able to see, right? So clearly he was not able to see the far away object. That means he is suffering from myopia. So from this discussion we know that myopia can be corrected by using concave lens. So the lens that we use here is concave lens. Now the last part of the question is the most important part, and here they ask what is the focal length. Find the focal length of the lens. Now we draw the diagram of human eye and we draw the distance up to which a person can see, and this is the region where he cannot see the object, right? So what we do, we use the lens. We use the lens and we place the object at the maximum distance. Suppose we place the object at infinity, and if this lens is able to produce the image of the object at 5 centimeter, then the person can see the object. Now if we decrease the distance from infinity to 5 meter, the image starts forming at this region. Further, if we place the object, then it starts forming at this region. So in this way we can say that the maximum distance where we place the object is minus infinity, and the maximum distance where the image can form is minus 5 meter. So now we use the lens formula, 1 upon V minus 1 upon U is equal to 1 upon F. Now 1 upon minus 5 minus 1 upon infinity is equal to 1 upon F. So from here F came is equal to minus 5 meter, or we can say F is equal to minus 500 centimeter. So in this way we have found out the focal length of the lens, and that came 500 centimeter. Thank you.